Alright, we are going to be graphing a parabola with a heck of transformations. Okay, don't worry, I wrote some steps here that I always use, and these are, they're not in the textbook, but they are very helpful, and I think they will benefit you and those who are struggling with transformations. I know how you feel. So these are my steps that you can use. Many people find them helpful. Okay, so we have a parabola today. We have 2 1/3 x plus 4 squared minus 3. Alright? Okay, so we know what this is. We know it's a parabola. Let's start with the steps. So the first thing, identify the parent function. Alright, so we just said this is x squared, right? You can see the x, you can see the squared. You know what x squared looks like, right? Yep. Something like that. A traditional curve. Okay. The second thing, so we got our first thing done. The second thing is make a table of values for the parent graph. Alright? So if we do that, let's start with -1. If you plug in a negative one in here, you get 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Alright, that's what I'll do. Okay, so great, we took care of that too. The third step, apply transformations to the basic graph, the basic table of values graph, whatever. So, what does this mean? Well, now we have to look at our given problem, given function. So we have to identify what is going to be happening. I'm going to write to the y's and x's. So we have to identify what is applying to this. What is different from this and this? Well, let's see. To our x's, remember, everything that is applied to our x's is in the bracket. Just in this range. Okay? So let's see. We are going to be subtracting 4, right, from the x, because remember, we are doing the opposite of whatever's inside the bracket. We're basically doing the opposite. Right? So this looks like you're adding 4, but no, you're actually subtracting 4. You're going to the left 4 units. Alright, so you're going to subtract, I'm going to write it here. Subtract 4. But mainly, see, this is what gets a lot of people kind of confused. They don't understand what to do with this. Well, you have to remember, this is still in the bracket. This if the 1/3 was where the 2 was, then that's different. But it's inside the bracket, it's just factored out, basically. Alright, so what you have to do, this value, you can do 2 things with it. I'll tell you mine after, but this is what it's supposed to be. You divide by 1/3. Alright, so you don't multiply because it looks like you're multiplying, but no, you divide by 1/3. All your x values, you're dividing them by 1/3. But because a lot of people don't like to hassle with fractions, you can multiply by the reciprocal. Because remember, 2 times 1/2, sorry. 2 divided by 1/2, this is the same thing as 2 times the reciprocal. Alright? Because when you bring this, if you want to bring this 1/2 over, up there, you have to reciprocate the 1/2, which is 2, and it's going to give you 4. Alright? So, just to get that clear. And same thing here, if you're dividing a value by 1/3, you can also multiply by the reciprocal. So you get 3a. I don't know, I'm just, Okay? So that's what we're going to do. I personally like multiplication. So I'm going to multiply by the reciprocal. Whatever this value is, you multiply the x's by the reciprocal. So what is the reciprocal of 1/3? Well, it's 3. So we are multiplying, not dividing, by 3. Okay? Now, so we got everything in the bracket. The 2's, remember, is just the graph. It's being squared. Now our y's. Let's take care of our y's. Okay. Now the y's, whatever you're doing to the y's, they are outside the bracket, as opposed to the x's when they were inside. The y's are outside. So here, what's great about y's, however it looks, that's how it is. Since you see a 2, you have to multiply by a 2. You don't have to do the opposite, the reciprocal, no. Just multiply by 2 and subtract 3. Right? Okay, so we apply transformations to basic graph. We did that. And now plot points. Well, before we do that, actually we really didn't finish this. We have to do the arithmetic. This right here is our basic x squared. But now we are changing this x squared by adding these crazy numbers, multiplying crazy things, subtracting, adding, to make this x squared look like this. Alright, so we are just taking each of these pieces and adding it, multiplying it slowly. Times 3, well, we're going to take care of that. Minus 4, that's right there. 2, there, minus 3, like that. And then we get our graph. That's it. So we're just doing it one at a time. Well, not really, but okay. We're going to do them all together now. So all you got to do is take the basic number, first x, and multiply by 3 and subtract 4, and you get your new x value for this graph. The same thing for the other ones, and same thing for the y. Okay, let's start. -1 times 3 is -3. -3 minus 4 is -1. 0 times 3 is 0, minus 4 is -4. Just going to do a little bit quicker. 1 times 3 is 3. 3 minus 4 is -1. Wait, did I do this right? Oh, no, I didn't. Sorry. This is supposed to be a -7. Sorry. -1 times 3 is -3. -3 minus 4 is -7. Sorry, guys. 2 times 3 is 6, minus 4 is 2. 3 times 3 is 9, minus 4 is 5. Just quickly do these ones. 1 times 2 is 2, minus 3 is -1. 0 times 2 is 0, minus 3. Did I do this right? I feel like 1 times 2 is 2, minus 3 is -1. 0 times 2 is 0, minus 3 is -3. 1 times 2 is 2, minus 3. Am I doing this right? I'm not doing this right. Yes, I am. Sorry. 4 times 2 is 8, minus 3 is 5. 9 times 2 is 18. 18 minus 3 is 15. Okay? I'm hopefully doing this right. If I am not doing it right, please comment, because I don't want to screw you guys up. I probably will. But here are your new x values. Okay? Let's graph. Now all we have to do is plot the points and graph. Forget about these now. Forget about these values. This is your parent graph. We are graphing the transformed x squared now. Okay? So let's make some. Make some. Okay. I'm making a big axis. It's because I want you really to see how the graph looks like. Okay, so we go -7, -1. minus 7, so 1, 2, 3, 4, 5, 6, 7, minus 7, minus 1, there. What's next? Minus 4, minus 3, minus 1, 2, 3, 4, minus 1, 2, 3, minus 1, 2, 3. Look right. Minus 1, minus 1, minus 1, right? Yeah. Minus 1, minus 1. 2, 5. 1, 2, 1, 2, 3, 4, 5. And 5, 15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so 5, we're all the way up here. So I hope you can see the graph. It looks something like that, roughly. My drawing skills are terrible, so you can imagine how bad I'm doing, but it looks on the range of this, something like that. Alright, so that's how, and just a little note, you can find your vertex, because this is in vertex form, right? So your vertex is right here, -4, -3. We even have it, -4, -3. Let's see, where is that? -4, -3, right there. That's our vertex. So it can't go lower. That's the lowest point. So you don't really have to make, find values, negative values. You can just, if you just got this side, just this side, then you can improvise and kind of add it like that. Anyway, thank you for watching, and I will see you guys in my next video. Alright, bye.